Now let's get into some ideal gas law calculations. So here we're given, we want to know the pressure, and we have a volume, we have grams, and we have a temperature. Okay, so here we're going to remember PV equals nRT. R I will give you, which is, make sure I tell you the right one before I just absolutely panic. 0.08206 liter atmospheres per mole Kelvin. That's the one we're going to be using. Just make sure yes. Okay, and if you don't have that programmed in your calculator, 0.08206. Now hit this store button right here over the on, and I'm going to store this as alpha R. It just makes things go a little bit faster for me. Okay, so now let's rearrange this. We want to know pressure. This is how most of you like to do it. It's not how my preferred way, but I'll do maybe the next one my preferred way. All right, so most of you want to rearrange this algebraically. So P equals nRT over V. Now follow it along. All right, we're already in kelvins. Who says, oh, but Dr. B, we're not in moles? That's okay. What's the closest thing we have to moles? Grams. Some of you are going to want to do that in a separate step. It's not necessary. Just put it all in one line. Grams. Now, oxygen gas exists how? O2. So be careful there. So 32 grams of oxygen is going to be 1 mole. All right, so look, there's our moles. That takes care of N. R. Get my pencil to work here. 0.08206 liter atmospheres per mole Kelvin. I always start with R. Cancel as you go. T, 302 Kelvin. Okay. Over volume, 15 liters, 15.0 liters. Okay. The only thing left here is atmospheres. That's a unit of pressure. We're good to calculate. 32.7 times, here, look, I'm just going to put R, because I stored that already, times 302, divide by 32, and divide by 15. 3 significant figures, so 1.69 atmospheres. And it doesn't say what unit it wants, so don't make it more complicated. Next, cylinder, we're given a volume, we're given a pressure, we're given a temperature, and we want to know N. All right, so here's how I do it. I just work things by units. It works out the same way if you rearrange it algebraically. I just put things in a different, I do everything using R. So it says how many moles. So that means I want moles in the top. So I'm just going to start here and put 0.08206 liter atmospheres per mole Kelvin. And then just use the units to cancel everything out. All right, so let's cancel out the kelvins. 298 kelvins. Okay, cancel out liters. 28.5 liters. Okay, cancel out pressure. 1.8 atmospheres. Only thing I have left is moles. That's what it asks for. If you rearrange this, you would find that N equals equals PV over RT. Look, pressure, volume in the top, RT in the bottom. So it works out the same way. I just don't have to memorize a gas law if I don't want to. 28.5, and I like to memorize as little as possible. Let's divide by R. And now let's divide by 298. Three significant figures are really two, probably 2.1. So let's go with 2.1. 2.1 moles. And it says oxygen gas. All right. Now, what is the temperature of moles at a pressure and a volume? We'll go back and do it your way. We want to know temperature. T equals PV over NR. Just rearrange Pivnert. All right. Now, here we go. Pressure is 1.3 atmospheres. And volume is 11.8 liters. N is 0.52 moles. And R goes in the bottom, 0.08206 liter atmospheres per mole Kelvin. If you have R programmed into your calculator, you do not get to write R in your calculation. Write out the units. I need to see where the units are canceling. It doesn't say what unit it wants the temperature in, so let's just leave it how it is. All right, so 1.3 times 11.8 divide by 0.52 and divide by R. So I got 359.5. All right. Now,